yeah.
Hi, my name is Anya,
Hi, my name is Arman, and we're
and
here
this is
to
our project for computing technology innovation
CTIP.
project. Yep, that's assignment 2.
Yes, and we're here to demonstrate a code. So let's share a screen.
I hope everybody can see the screen.
Yep.
Okay, so I'll just dive into my code. That is the machine learning model. For the very first snippet, we have just read the files using pandas, and we have combined them into a single dataset. It is uncleaned. And I'll run the code from here. We had already set up the environment using conda commands. And here you can see the data set. It's got 11,000 rows. And further, we'll try to clean the data and create machine learning models with these. I'll save this combined weather data into a data set, like an unclean data sets.csv. And further, I will create a heat map. Visualization tools are very important. We can clearly see the gaps here, and we'll try to rectify these. If I move further, here we have counted the number of rows which have empty cells so that we can fill these data. Furthermore, I have calculated the percentage of the empty rows. For the valid columns, we'll just include those columns which have less than 50% of the data is missing. Furthermore, here I have just copied that valid columns dataset into my variable. And later I have filled all of the missing values using the mean of the entire column. And now we have no rows missing. Outliers can be problematic. So here we have handled outliers so that our data is scaled. I also added feature engineering by adding 2 more extra columns like temperature range and wind chill. We have saved this cleaned dataset into a new combined.csv. And after cleaning, if we create the heat map, we can see that there are no missing columns. There are no gaps between any rows and columns. Now I'll split the data into training and testing. 80% for training and 20% for testing. Arman, you can take over.
Thank you, Sana. So, of course, after splitting the data into training and testing, we were required to train our models and use different models to test our prediction for Tmax and Tmin. First of all, we used a linear regression model because, of course, it was the most basic model that we felt required to use. And for this model, the MSC and the R square we had was 5.26 and 0.9, which was pretty high. So for the next model, we used the random forest regression. In this random forest regressor, it uses different trees and asks different questions to the model and predicts the temperature. So the estimators we had is 100, 100 questions. So we ran this, and MSC was pretty less for this one, which was 3.63, and RSQ was 0.9. But we thought to use another model, which was a gradient boosting regressor, which so the difference between the gradient boosting and the random forest was that the gradient boosting has independent trees, and but the R square has just the mean trees. So, to our surprise, the gradient boosting had a really low error of 3.55 for the MSC and 0.95 0.97 for the R square. So, which made us believe that it was the best model. But yeah, of course, to increase our functionality and our accuracy, we used two more models, which was lasso and ridge regression. We ran this, and of course, the errors were pretty high, but we got to know that gradient boosting was the best model we can use for this. Then of course, we then uh, split the data into training, and then we use the classifier model, which was our next functionality of our like of our project, which is classifying the models into the rainy, sunny, and windy things. So for this, we use a random forest regressor, and we got a pretty much good accuracy of one, and all the things were pretty well. And then we added one more functionality into a model, and used by using random forest regressor, which was predicting the energies of by getting a term like the energy consumption rate. And for this, we use a random forest regressor, and the MSC and R square we got was pretty good, like 0. 0.3 just for the MSC and 0.99 for the R square, which like made the model really good. Then we saved the model to joblib, and yeah.
Okay, so
So Sanya,
furthermore, what
can-
we did was we had to retrain the models using an additional data set. So we took Tokyo and Bombay as two different cities and combined their weather, like combined their data sets to retrain our models. The clean, like the way they were cleaned, has already been included in the file which we submitted. So we clean these files, then we have these Tokyo.csv and Bombay.csv, which have clean files, no missing data, all the outliers are done, everything. We combine these, and here we can see the combined data set for these. So the null percentage is 0 because there is no data missing. The total null percentage of additional data sets is 0. Furthermore, we split the data again into training and testing. And now our gradient boost regressor, we retrained it, we imported it using joblib, and we retrained it, and we got a lower error than before, which was 2.6 and 1.9, which means our models are getting better with the enhanced data sets. Also, for a random forest regressor, we retrained it using the same way, and the error we get was much lower. You can see 0.1 for the MSC and 0.99 for the R square. Also, here in this code snippet, we were still not sure. So we compared the Tmin and Tmax using linear regressor, then random forest regression and gradient boost. So the Tmin and Tmax comparison is, just give me a second. Here we can see. So the actual Tmin was 4.3. The random forest predicted at 5.2. Linear predicted at 5.15. And GBR, that's our gradient boost, predicted at 4.6, which was the closest one. Hence, we chose GBR. Now, using the test data set, which we had already split, we will predict the Tmin and Tmax. So here is the final output, which was done using the test data set. We can print our additional data sets, and there we go. That's our correlation heat map. Arman, will you take over the visualization?
Perfect. So yeah, so for another things, we also added models because visualization is a great aspect and important plays importance in like the model selection and to see how our columns are doing and how our models are working well. And of course, for the visualization, we have made two data sets, imported two data sets into the file, like uncleaned and cleaned. And for the first visualization, we chose histogram because it clearly depicts how like what's the size of a variable and how it's doing. So for the data before cleaning, that's our histogram. Perfect. It's look a little bit disoriented because it's still uncleaned. And then it's for this. This is for the clean one. That's the best bell-shaped histograms and figures that makes us believe that the like linear regression models and the gradient boosting will work best for us. And for the next part, we believe that like the scatter plots and everything was the best resolution tool because they're colored by wind speed and like the Tmin and Tmax are clearly depicted over here. And after the cleaning, that's what our scatter points looks like. The middle ones, like the darker color you see, is the higher wind speeds, which makes the model learn the patterns and everything, and of course helps to us get a lower error. So yeah, perfect. That was our visualization tools and the enhanced ML, I mean the code you saw, and that's our project sum up in a video. Thank you very much. I hope you are impressed now.
Thank you.
Thank you.